9.4, solving quadratic equations by completing the square. So what does completing the square mean? Key vocabulary. For the expression x squared plus bx, you can add a constant c to the expression so that x squared plus bx plus c is a perfect square trinomial. So I wrote down y equals x squared plus bx plus c because the first thing you're going to do in completing the square is you're going to find half of b, and I highlighted b in yellow. You actually want to take the sign in front of b as well. So you're going to find half of b, which is the coefficient in front of x. And then for step 2, you're going to square the results from step 1. And finally, for step 3, you're going to add the results from step 2 to the expression x squared plus bx. So let's try that for example 1. We have the expression x squared plus 6x. Our b is positive 6. So for step 1, it told us that we're going to take that number and divide it by 2. So we get 3. For step 2, we are supposed to square what we got in step 1, which will give me 9. And then for step 3, they want you to add that to the expression x squared plus bx. So that's x squared plus 6x for this example, and we're going to add 9. Now, realize when I move on to example 2 and 3, I'm going to actually add to this side 3 squared, which is equivalent to 9. You'll understand why in a little bit. Okay, so I want to jump into our regular notes and show you completing the square using algebra tiles. So we started using algebra tiles in school, and really I wanted to bring in algebra tiles for this specific lesson. So I wanted to get you acquainted with them before completing the squares. Unfortunately, we don't have the algebra tiles in front of us at our classroom right now, but I'm going to show you virtually. So this, if you remember, represents x squared. So this would be x squared, and each one of these green rectangles would be just x. So we'd have x, x. All right, so this is very similar to, this is actually example 1, part A. We have x squared plus 6x. So when they call it completing the square, I want to take these algebra tiles and I want to make them into a square. So right now when they're lined up, it looks like this rectangle. But what if we manipulate these and move them? So let's move this. If I move this here, and I lose my x's, but that's okay. This didn't make it look exactly like a square, unfortunately. So how do you think we can manipulate it and make it look like a square? Well, if somebody said, why don't you rotate these, that would work. So now I have my x squared plus 6x rearranged so that 3 of the x's have moved horizontally. Okay, this still is not a square. I need to complete it. Well, what I showed you on your notes is you would take the b coefficient, so that's 6 divided by 2, you end up with 3, and then you square 3 to get 9, which means I need to add 9 to this expression in order to complete the square. Oh, check it out. If I added 9 squares there that are represented by 1, that would complete it, which I happen to have right here. So if I highlight this, let's see if I move it up there. So when I move these, you now see that we have completed a square, and we have x squared plus 6x plus 9 to complete that expression. For example 1, part B, the coefficient in front of x is negative 9. So if we have x squared minus 9x, we're going to take that negative 9 and divide it by 2. Now this is not going to give us an integer, so I'm actually going to keep it as a fraction. For number 2, or not number 2, but step 2, we're going to square that. So I have negative 9 halves squared, which gives me 81 fourths, because negative times negative will turn it positive. 9 squared is 81, 2 squared is 4. For step 3, we're going to add that to the x squared plus bx. So that's x squared minus 9x in this example, and we're going to add 81 fourths. Okay, now when I go to solve this, you may see this, x squared minus 9x plus negative 9 halves squared. And I'm going to keep it in the parentheses because it's negative. All right, so for example 2, we are now going to solve the quadratic equation using the method for completing the square. So if I have x squared minus 16x is equal to negative 15, for step 1, we were supposed to take the b, which is the coefficient in front of x, and divide it by 2. So negative 16 divided by 2 gives you negative 8. For step 2, we're supposed to square that, and you end up with 64. Okay, what I want you to watch is the way that I add these into both sides of the equation. So you know the rule, whatever you do to one side of the equal sign, you must do to the other. I'm going to leave a space. After minus 16x, I'm going to leave a space, and then I'm going to write equals negative 15, because I have to add the same thing to both sides. But the way that I write it is going to be a little bit different on both sides. On the left side, I'm actually going to write this. I'm going to write plus negative 8 squared. And then on the right side, I'm actually going to add this, plus 64. Technically, negative 8 squared is equal to 64, so I have added the same thing on both sides. The reason I do this is because to solve this, we need to factor this side. And if you leave it as negative 8 squared, it's already giving you the answer on how to factor it. So this really is x minus 8 squared. And if you're like, ooh, how did you get this? Well, let's look at it this way. Had I not added negative 8 squared and added 64, so x squared minus 16x plus 64, you could do this if you want to do it this way, but you would have to sit there and think, okay, what two numbers added together give you negative 16 and when multiplied give you 64? Well, that would be negative 8 and negative 8. I just keep it this way, and that tells me how to factor it. Okay, so now on the right side, we have negative 15 plus 64. So negative 15 plus 64 is going to give you 49. And you know how to solve this. We showed you how to solve these in section 9.3. So now we're going to take the square root of both sides. So this cancels the square. And on the left side, we have x minus 8 equals, and then on this side, we have 7, but remember it was x minus 8 squared, so plus or minus 7. Now let's solve, and we have x minus 8 is equal to positive 7, and x minus 8 is equal to negative 7. So when you add 8 to this side, you get x is equal to 15, and when you add 8 to the other side, you get x is equal to 1. And those are your two solutions, 15 and 1. For example 3, solving a quadratic equation, ax squared plus bx plus c equals 0, what we have now is a number in front of x squared. So we have a coefficient. So let's rewrite the equation. We have 2x squared plus 20x minus 8 equals 0. When we complete the square, we just want x squared plus whatever x is being multiplied to x on one side and the constant on the other. So let's move this 8 to the right side. And we have 2x squared plus 20x is equal to positive 8. Now, we can divide every single one of these terms by 2. So when I divide everything by 2, I get x squared plus 10x is equal to 4. And this is very nice because we don't have a coefficient in front of x squared. We don't have an a. Now, let's write x squared plus 10x. Let's leave a space because we're going to add something to the left side, and whatever we add to the left, we'll add to the right. So let's figure out what that is. The rules for completing the square. Step 1 was that we were going to take the coefficient in front of x squared, the b, and divide it by 2. So 10 divided by 2, that gives us 5. Step 2, we are going to square that. So 5 squared is equal to 25. Now for step 3, we're going to add that to both sides. So I'm going to add 5 squared on the left side, and on the right side, I'm going to write it differently, but it's still equivalent, but I'm going to add 25. So now, when I go to factor the left side, it's just x plus 5 times x plus 5. And then we can write this as x plus 5 squared. On the right side, we have 4 plus 25, which is 29. To solve this, we're going to take the square root of both sides, and it'll be x plus 5 is equal to plus or minus the square root of 29. And in the directions, it said we are going to round to the nearest hundredth. So to solve for x, we're going to subtract 5 from both sides. So your final answer, well, not final, but you'll have x is equal to, we have negative 5 plus or minus the square root of 29. And you're going to put that into your calculator 2 different ways. So we'll have negative 5 plus the square root of 29 and negative 5 minus the square root of 29. And when you do this, you end up with approximately 39 hundredths for this answer. And over here, you get approximately negative 10 and 39 hundredths. And those are your 2 answers.